My name is Carlos Ferreira. I'm a Principal Offering Manager with Maximo Asset Monitor. We're going to be covering Anomaly Detection, Part 3, which is configuring anomaly detection functions in Monitor. And the first steps we're going to be doing is picking specific assets to look at and metrics to look at. The metrics we'll be looking at are minutes run status. How many minutes every 5 minutes is this running? If it's running 5 minutes, it means it's running full time. If it's running less than that, it means it's not running optimally, achieving 100% SLA. So what we're going to do is we want to pick an entity, and the way we isolate functions on anomaly detection functions is by using the entity filter. Entity filters will allow us to isolate our anomaly detection analysis to specific asset IDs. And then we will also do a filter to make it focus on a specific metric as well. So that'll be the first steps, identifying the entity filter to pick the entity. In this case, it'll be 7,300, 73,000 that we'll be looking at, asset 73,000. And then we'll also pick the metric that we'll be looking at. So this is the assets, the 73,000 asset that we're looking at in terms of the identifier. And these are some of the metrics that we're collecting. We're collecting pressure, temperature at the inlet and outlet. But in particular, we're interested in the minutes run status. And this is the current view of the minute run status. You can see here, it's actually running 5 minutes every 5 minutes. So it's running at 100% utilization. But if I look back at the last month, I can see here that when it initially got started, it wasn't running properly. It was up and down, up and down. So it went from a moving state to a simple state. So we're going to pick the entity filter to pick that specific entity, which is 73,000. And so we'll search the catalog, and then we'll identify the entity ID to use, which is 73,000. So this is going to tell Maximo to go and pick just entity 73,000. And that's what we'll give it as a name, entity underscore 73,000. And this will return a value, a Boolean value of true, meaning it was able to only get that entity out of all the entity types that existed. The next thing we'll do is that will be input into our next function, which is to pick the metric that we'll be analyzing. So for this one, we'll pick the filter, and we'll only look at that specific entity. So we'll pick the entity ID, 73,000 that we just created. And then we'll pick the expression that we'll look at, which will be the actual metric that we'll look at. So we're going to pick the metric here. And the metric will be the run status that we were just talking about. So scroll down, and we'll go ahead and pick the run status. It's right here. Yep. Okay. And now we're going to say the expression is we want to look for that run status in entity 73,000. And then we're going to pick the output value. The output value will actually be the metric. So we'll come over here, and we're going to call this, we use a naming convention. So the naming convention will be run status entity 7300. So this will actually be the metric that will go into our anomaly detection model, our anomaly detection function. So let's go create our anomaly detection function now. Okay, so to add an anomaly model, we go up to the catalog, add function. We're going to search for the spectral anomaly. This is the one that detects flatline anomalies. And we're going to configure a window size. The window size is how many data points, metrics, time series points it's going to look at. We pick the metric we're going to be analyzing. In this case, it's the metric we filtered earlier, which is run status for entity 73,000. That will be what we'll analyze rather than metrics from all the other ones. And we're going to use a naming convention with score at the end for run status for that entity. It'll take 5 minutes for Monitor to run and get a score for that model. And in the meantime, you'll see the calculation is scheduled in the UI for that function. Configuring anomalies is to add the alert score to the line series chart for the minutes run status so that we can see how well the anomaly score is correlating with the actual metric where the anomaly happened. So we're going to go into the dashboard that had the minutes run every 5 minutes, the line series chart, and we're going to go ahead and edit this dashboard and add a metric for the anomaly score to that. We're going to export the JSON for the dashboard. We're going to edit the line series chart for the minutes run status. And we're going to add a new metric to that as a data source, which is the anomaly score for the spectral anomaly model and function that we just added. So we'll go into the data source attributes for the run status time series. We'll add a new attribute called run status entity 7300 score using our naming convention. And that will then add the score to our line chart. We'll also give it the same ID identifier as well. So once it's in the data source, we can also go ahead and add it to the series in the content section as well. So we'll go down to the content section of this line series card. And this is where we add a label to this new calculated metric, which is the run status entity 7300 score for the spectral anomaly. So we can modify, copy the one above, and then just put it in, and we'll give it a new label that reflects what it is. It's the score, right, for the spectral anomaly. So we'll just update this to reflect that it's the anomaly score. So after we save this, we will re-import it into the dashboard. And after 5 minutes of running, we should have anomaly scores that will then be displayed. Now the score is a reflection of how likely there is an anomaly. The higher the score, the more likely an anomaly has occurred. So let's go ahead and save this. And now let's go back to the dashboard editor and import it as well into the dashboard. Go ahead and import the file. Clicking on import, we pick the JSON file that we've added the anomaly score to. And once we save this, the dashboard will reload. And we're looking at asset ID 73,000. Recall, we set the entity filter and metric filter to only apply to this asset. We go to the card, the minutes run every 5 minutes card that we want to look for the flatline condition. And you can see now we have 2 lines or 2 metrics here, one for the score. We go back in time to see what the scores look like. In particular, when we had that flat line, when it went from a varying line to a flat line. So we look 1 month back, and this will allow us to see whether there's a correlation between a high score. In this case, there's a very high score from when it went to the varying signal in purple there. You can see it's varying up and down to a flat line. And you can actually record mentally what the score is. It's over 400, so that in the next step, we'll be setting alerts. And so if we look at another asset, 73,001, we'll see a couple of behaviors. Because we use the entity filter and filter to choose the metrics, the cards are actually smart and realize that even though you have one JSON dashboard template that has 2 data sources, that data source and metric was not supposed to be rendered in any other asset ID instance dashboard except that one for 73,000. So that's why 7301 does not have one. The next step is configuring the anomaly size window. understand the difference between window size and how frequently a function is scheduled. On the very top in orange, this represents raw metric data that's being collected, similar to our run status, that shows how the yellow boxes are the anomaly. The rows below that in black are the different options for selecting either the schedule of how frequently a function is run, and also the sample size window. So the green boxes represent 12 sample window sizes, data points. And the first row shows how you run the metric by scheduling it every 5 minutes. It will operate on that 5-minute raw data. And therefore, it's the fastest to detect the anomaly. But because it runs every 5 minutes, it is very resource compute intensive. The option below that runs every 20 minutes because each box represents 5-minute intervals. So this is the best option to compute and time to detect it. It'll take about 20 minutes when it detects that high point. The third row is actually the best in terms of resource compute. It'll run every hour and it will detect the anomalies, as you can see. By running every hour, it runs only after having 60 minutes of data, which are 5 times 12 data points. And the fourth option is going to miss the anomaly completely because the sample size window is 12. However, the function was scheduled to run every 75 minutes. And so there you can see how it actually misses the anomaly. So you got to be careful to make sure that you schedule your functions as appropriately to detect the data of anomalies. So next, let's go ahead and adjust our function for the anomaly score to run only at once a day. And instead of running every 5 minutes, we want to save compute resources. So we're going to schedule it to run every 60 minutes. And so with our sample size of 12 and 5-minute data, this will run once every hour. I save it and it will recalculate the scores for that function. So we move on to the next step, step 4, which is, creating an alert. And there's different types of alert. We're going to create an alert expression with filter. This will look only for scores greater than 500. Remember, that was the score, and we're going to use our naming convention for alert. So now we have an alert that will look for a score greater than 500, which is what we wanted, and it'll calculate that. So when we run the alerts, what's going to happen is there's going to be no recent alerts because if you recall, that flatline condition happened about a month ago. But to be able to see the alerts, we have to add the alerts to make red dots on our cards. And to do that, we add this additional data and to the JSON. And that additional data will then render on that card that we have a dot representing the alert. So let's do that now. We're going to modify the JSON to put a red dot right on that 500 point there when it went from the variable to the flatline condition. We export the JSON again, like we did last time, out of the dashboard. And what we're going to do is we're going to copy and paste into that card the JSON data, which is additional data, which represents the alert. But to be able to get the alert, you need to actually have alert time series data in there. So we're going to go ahead and add that. Okay, the other thing we want to do is remove time grain day there. We want raw data to show up on our cards. And by removing that, we'll get raw data as opposed to data that's kind of aggregated by day, for example. We save our JSON file for our dashboard template. and then we import it back in to Maximo Asset Monitor. We pick the card, import it in, and now we should, after we import it, be able to see the red alert dots show up on our cards that represent the time that the anomaly happened. Um, so the data will reload again and recall. So this is looking back past the last month. You can see the red dot is there and where it went from a noisy line to a flat line. And you can see the raw grain of the run status going from noisy to flat line. And you can also toggle on and off the score so you can see how that's performing as well. Do two more steps to finish this off. We're going to add an alert table that summarizes our alert scores. This will allow us to see for not just the run status, but actually for all the metrics. It'll summarize all the alerts on this asset. The other thing we'll do is we want to be able to show and look at that service, create a service request on anomalies and alerts. So I will show how to do that as part of that alert table, which is a nice functionality. It'll create a service request in Maximo. Finally, if I need the data to do that analysis as part of that service request, I can save the data from the card into a CSV file. So we'll show how to do that piece as well. So we export the JSON and we add a new card called an alert type card. And that's what you see here. There's a type alert card that you add, and that will add the alerts table. You can also augment this with dimension data to filter the alerts using information like the site, the business, for example, so that you can quickly scale and filter alerts specific to that. So we make our modifications and then we import the JSON file. And as soon as we import that, it adds the alerts into our summary dashboard. We can then filter those alerts by clicking that funnel and then typing the name. So remember, we called our alert a run status for that entity. And so I'm able to quickly type ahead and filter those. I can create a service request by clicking on the link there, and that will actually open up a Maximo service request for that. And then if I go into the card itself, I can actually click on the expand button and then the download CSV file, and that will save the results of the anomaly into a CSV file that I can then share with the data scientist or whoever else. Test your anomalies to make sure that they're working. In particular, you want to make sure that you don't set a threshold too low, which would cause you to get too many false alerts, too many anomaly alerts, or vice versa. Don't get a false sense of comfort because you've set your threshold for alerts too high and you've missed some anomalies. The other thing is once you've tested your model, you can share it on the Digital Twin Exchange. We just announced that this year. The Digital Twin Exchange is a great place to share anything like your simulated data for your model itself, the templates to display the data in a dashboard. And this is so that a pump manufacturer, for example, could share their simulated data, their dashboard templates with other customers and service providers that would want to use those in their dashboard and for other purposes as part of supporting the maintenance of that. Thank you for listening.